Okay, the next chapter is basic editing. It's also the sixth chapter of the solid modeling basic. In this chapter, I will show you how to do some basic editing operations, such as pattern, mirror, move, rotate, and etc. Now let's get started. First, let's talk about pattern geometry. And in ZW3D, geometry means shape, face, curve, point, sketch, datum, etc. And in this page, you can see we just take a solid shape as an example to show you the 8 methods to create a pattern, which are linear, circular, polygon, point to point, add pattern, add curve, add face, and the fill pattern. You can quickly go through the slide, and later I will show you directly in the software. Okay. And there are some common options in pattern commands. First one is derive the pattern. This option is indispensable in circular pattern, which means you can create pattern only by pattern number or pattern space, and the other parameter will be calculated automatically. Next option is toggle instances. This one is easy to understand. We can use it to select the shapes to remove. And the next option is alignment. We can align each instance identical to the base object, or align the instances with the axis of rotation. And the next one is stagger. If you check the option, it will stagger the instances by half the pattern distance. Here you can see the result difference in the below figure. Okay. And the next option is associative copy. As its name implies, check it or not, the pattern will be associated or unassociated with the original geometry. And the last option is a boundary. We can specify a boundary to limit the pattern, and it can be inside the boundary or outside the boundary. Okay. And after pattern geometry, next I will introduce pattern feature. In ZW3D, fillet, chamfer, hose, rib, draft all belong to features. In ZW3D, we also provide 8 methods to make pattern for single or multi features. And almost all the options are similar to pattern geometry. Okay. Just now I said almost all because there is still a little difference. For example, the variable pattern. This is only available for pattern features, but not for pattern geometry. So with this option, we can change the feature size as you pattern them. Okay, now let's move over to ZW3D to show you more details. Okay, first let me show you how to create a geometry pattern. Okay, and here you can see we've got 8 methods to create pattern geometry. The first one is linear. This one is easy to understand. We just select a base and we select a direction. And then we define the number and the spacing. Like here we use 11. Okay. And also we can make it in both sides, like this. Okay. And also we can make the pattern for the second direction. Here we make second direction here. Okay, and then we make the number and the spacing. Okay, it will be the result. And also for the second direction, we can also make it both sides. Okay. Click OK. We click OK to check the result. And there are some settings I mentioned in the PowerPoint. Here I will show you one by one. The first one is instances to toggle. This one is easy to understand. If you do not need some instances, you can just toggle it. Okay, something like that. If you click OK, it will disappear. Okay. And The other one is about stagger, which means if you check the stagger, it will stagger the instances by a half distance of the pattern. Okay, this is the result. And the next option is about associate copy and non-associated copy. So by default, ZW3D will check this option so that if the shape is changed, the pattern's instances will be also changed. But if you uncheck it, and then you can see there will be no pattern feature, just some shapes. Okay. And the second method is circular, which is also a commonly used method. Okay, now we can see how to use it. Pattern geometry, and we select the second one, pattern by circular method. And also we need to define the base shape. Okay, and we define a direction. Here is a Z, and then we define the diameter, like 60. Okay, here we uncheck the stagger. Okay, and the number we can make it a 10, and then we can make the angle. And for a circular pattern, there is an important option which is derived pattern. So as I said before, if you check the derived pattern, you can create pattern only by pattern number or pattern space, and the other parameter will be calculated automatically. Now let's give a try. If we select spacing, then you can see we only need to define the number, and the spacing will be calculated automatically. Okay. And if we select a number, then we only need to define the angle, and the number will be calculated automatically. Okay. And for circular pattern, we can make the second direction like this. We can make the number and the spacing. Here we just make 3, and we change the spacing as like 50. Okay, then you can see the result. And here I would like to show you another option, which is boundary. Here you can see we have a rectangle boundary, and here we can use the boundary option to select the boundary, and then we can set the margin and exclude the mode or include the mode. This is exclude mode, and this is include mode. Okay. And the next one is polygon. This one is similar to circular, so we can also define the base and then direction and the side of the polygon. Then we can get a result as below. Okay. Next method is point to point. Now let's see how to use it. Pattern geometry, and also we need to define the base geometry, and we select the destination points. Here we have a little trick. Because all the points are located in the same sketch, so we can use the right menu, and we select the sketch points command, and we just need to define one point, and then all the points will be selected automatically. Okay, then we can click OK to get the result. The next method is add pattern. This one means you can create a new pattern based on an existing pattern feature. So for example, here we got a pattern for the bolt, and next we want to create a pattern for the nut. Now let's see how to use it. Pattern geometry, and we select the nut as the base, and select the existing pattern, and we click OK. Now we can get the result. The next method is add curve. So which means you can create pattern based on a single curve or multi curves. Okay, now let's see how to use it. And here you can see we can choose one curve and multi curves. Okay, so first we define the base, and then we define the boundary curve. Here we can use the second one by 2 curve. Okay, and then we define the number 5, 4, and once the instance beyond the curve, it will be not generated. Like here, if we create 8, you can see it's not generated. Okay, we make it 6, and also we can define the pattern for the second direction. Okay, we can make it 3, and we can make the spacing as 20. Okay, then we can get a result as below. Okay. And the next method is pattern at face. Okay, this one is similar to pattern at curve, but the difference is the limitation is not curve but a face. Okay, so similar to the former one, we need to select the base and we define a face, and then we can define the number and the spacing, because here we use the derived pattern. Here we can make the number as 4. Okay, and we can also do the pattern for the second direction. Like here we make it like 8. Okay, then we can get a result like below. The last method is fill pattern. Okay, now let's see how to use it. First, we need to define the type. There are 6 types to define the fill pattern: square, diamond, polygon, hexagon, concentric, spiral, and a long sketch curves. Here we'll use the spiral as an example. Okay, first we define the base, and then we define the sketch region, and then you can see the preview. Here we can change the radius bigger, like 30. Okay, now you can see it's a spiral shape, right? From inside to outside. Okay. They say about the fill pattern. And after pattern geometry, next I would like to show you pattern features. Okay, here we use this as an example. And here you can see we have 3 features here: a rib, a fillet, and a hole. Okay, now we can use the pattern feature. Okay, and also you can see we have 8 methods to create the pattern feature. Okay, so here we just use the second one, the circular pattern. Okay, first we select the base, the rib, the fillet, and the hole, and then we define a direction. Okay, and then here we use the derived pattern. Okay, we make it 3. Okay, now you can see the result. And as I mentioned before, for pattern feature we have an advanced option which called variable pattern. Okay, here we use this as an example. Okay, here we use pattern feature, and here you can see we have a curve. Then we use the pattern at curve, and the base is the hole, and the boundary is the curve. Okay, and here we can make the number as 8. Okay, and you can see by default all the pattern instances is exactly the same size with the base feature. Okay, so this is where we can use the variable pattern. Okay, and here you can see for variable pattern we have several types. Here we just use the first type as an example. Okay, so first type we need to define the parameter of the hole. Okay, here you can see once we move our cursor here, you can see the parameter of the hole will be displayed. Okay, for example, we select the diameter of the hole. and then we define the increment like 2. Okay, and then we click OK. Now you can see the result. The hole will become bigger and bigger along the path. Okay. Okay, this is all about the pattern geometry and the pattern feature. Okay, next let's talk about mirror. Comparing to pattern, mirror is much easier to understand. Similar to pattern, ZW3D also provides 2 mirror commands to deal with geometries and features. Later I will show you in the software. Okay, now let's move to the next page. In this page, I will show you some transformation tools, such as move, copy, rotate, and scale, which are very basic but important commands. For move, rotate, and copy, actually they go always hand in hand. So we will just take copy as an example to show you the 6 methods to create. They are dynamic, point to point, along direction, around a direction, by aligning frames, and along path. And later I will show you directly in the software. And besides the 6 methods I mentioned just now, ZW3D also provides an advanced tool to move or align the geometry, which is similar to assembly constraints. We can move the geometry by coincident, tangent, concentric, parallel, perpendicular, and angular. Okay. And the last feature is scale, which is easy to understand. We can scale the geometry along X, Y, Z directions. Now let's move over to ZW3D to show you more details. Okay, first I will show you the 6 methods to create a copy. Okay, the first method is dynamic. Okay, which means we can move or we can rotate the shape by the handle. Okay, this is the result. The second method is point to point. Okay, we select the entity and we select the start point and the end point, and we click OK. Now you can see actually the result is what we want because all the shape is buried in another shape. Okay, so we can change some settings. Okay, so here you can see we've got an orientation option, in which we can define the start vector and the end vector. Okay, so for the start vector, which is actually the normal direction of the top face. Okay, we can use a right menu, face normal. Okay, this is the start vector, and the end vector is the face normal of the side face, right? Okay, we also use the face normal, the side face. Okay, now you can see this is what we want, right? The next method is copy along a direction. This one is easy to understand. We just define a direction and then we define the distance and also the copies you want. Then you can get the result. Okay. And the next method is rotate entity along a direction. Okay. Here we select the base entity and then we select a direction. Here we can use the face, the center line of this face as the axis. Okay, and then we define the angle and the copies. Angle we make it 30 and the copy we make it just 2. Okay, now you can see the result. And the next method is copy by frame. Okay, so here we can see how to use it. We select the entity to copy and we select the start frame and we select the end frame. Then you can see the result. It will align with the frame. Okay. The result. And the last one is copy along a curve. So now let's see how to use it. We also select the entity and a curve at the path. And then we can define the points, the destination points, 1, 2, 3, 4, and 5. Okay, and click OK to get the result. Okay, next I will show you the align move command. Okay, we use this case to show you. So for align move, we can make something like assembly constraints. Okay, now let's see how to make it by align move. We click on align move, and then first we define the fixed cylinder face, which is this one, and then we define the movable cylinder face, which is this one. Okay, then you can see this two cylinder is concentric this time. Okay, we click apply, and then we continue. Here we need to add a coincident relations. We use the coincident and also the movable face and the fixed one. Okay, and also we can make it same facing or opposite. Okay, now you can see the result. It's exactly what we want. Next, I will show you the last command of the basic editing, which is a scale. Now let's see how to use it. First, we define the entity to scale, and then we define the method, uniform or non-uniform. So for uniform, it's easy to understand. We can scale in the XYZ direction with the same factor, like 2. Okay. And for non-uniform, which means we can define different scale factors for the different direction, like 1.5, 2, 3. Okay, now you can see the result.